Okay, so the question here is, what is the exact numerical value of this number? It's looking quite frightening because it's a cube root of something which has got a square root, and then you're subtracting something which is similar to that. And without a calculator, this looks as if this is impossible. But now you will see the power of mathematics. Most of the mathematics you know to see how you can solve this problem. All right, so let's give a name to this. We'll give a name to this thing here. Let's call it A, and the whole thing B. So A is equal to the cube root of 5 root 2 plus 7, and B is the cube root of 5 root 2 minus 7, which means that A cubed is equal to 5 root 2 plus 7, because A is the cube root of this. And our problem is to find what is A minus B. So remember, that is the goal, find A minus B. All right, so immediately we can write down B cubed is 5 root 2 minus 7. And we can get an A minus B from these two things, because if I subtract these two, A minus B is a factor. The difference of two cubes, one of the factors is A minus B. So let's subtract these two, and what do you get? 14. Those two cancel, and you get 14. So this is A minus B. This factorizes into A squared plus AB plus B squared equals 14. Okay, we don't know what this thing is. Let's call it X. So X is your unknown. So you've got X here into A squared plus AB plus B squared equals 14. All right, now we need to get X's here. I've got A squared plus AB plus B squared. How do I bring in an X into this? Well, it will certainly look as if it looks something like A minus B all squared. All right, so you can bring in A minus B all squared is A squared minus 2AB plus B squared. All right, so to get this, you have to add 3AB to this. So A squared plus AB plus B squared. Now let's write that in terms of X. It's A minus B all squared plus 3AB. If I add 3AB to this, then I'll get the AB in the middle. Okay, so I've got X here. That's X squared plus 3AB. All right, but we still have the AB lingering around here. I need to get an X there. Now let's go back to what A and B mean. So AB is a product of A and B. Why not try to work out the product A cubed, B cubed? What is A cubed, B cubed? Because then we might be able to work out what AB is. A cubed, B cubed, multiply. So this times this, that's 5 root 2 plus 7 into 5 root 2 minus 7. And this is the nice friend. It's the difference of two squares. A plus B into A minus B. So that's 5 root 2 A squared minus B squared. Right? A plus B into A minus B is A squared minus B squared. But you got A and B are given these values. Now you can square this. It's 25 plus times 2. So that's 50. And this is 49. Oh, and 50 minus 49 is a lovely number, which is 1. So AB cubed is 1. So AB would be the cube root of 1. And AB is therefore equal to 1. So let's go back to the equation which started this all. And there it was x into so this is x into, and we just saw that this thing here is x squared. I think there is x squared, and we saw that this is 1. So it's x into x squared plus 3 is equal to 14. Now that's a nice equation, but it's a cubic equation because you got x times x cubed. And you don't know how to work out a cubic equation, but just do it by inspection. Try some values and see what happens. And you will see when x equals 2, you'll have 2 times 4 plus 3 is 7. That is 14. Right. So x equals 2 works. So therefore the answer to this problem is x equals 2. And that is your a minus b. And it's that, in other words, the question itself. So it's a beautiful application of just simple algebra. Okay, difference of two cubes, a square of a binomial, and a little bit of adjustments here and there. And there you have it. Okay, so let's get on to the next one. The answer to this problem is 2. You can put the stuff into a calculator and you'll see you'll get exactly 2. Okay. So let's get on to the next problem. The next problem says, determine the smallest positive integer n so that 2019 divides. So you got, this is an integer, positive integer. So when you substitute a positive integer into this, you're going to get another positive integer. So you want to know 2019, it's going to be a factor of this. It divides it. So maybe there are some values of n which will make this into a factor. Now, and the question is now, of all those values of n, which is the smallest? All right, so let's first try to see, take this n squared plus 20n plus 19. Now, that can actually factorize. This is n plus 1 into n plus 19. Right, you can check this thing out very quickly. So this factorizes. Now, I think I mentioned that when you write on factors, there's a nice way of writing down factors. You just put a vertical line. And that will be, you read it as 3 is a factor of 6, or 7 is a factor of 35, and so on. A vertical line, you read it as is a factor. So you are told that 2019 divides this, which is the same as saying that 2019 is a factor of n plus 1 into n plus 19. Okay. Now, this is a very big number, but it does factorize. You see, in that year, this obviously occurred in the year 2019, this problem. So this is 3 multiplied by 673 is a factor of, so this means that 3 is a factor of this. N plus 1 into n plus 19. And 673 is also a factor. If 3 is a factor of the left-hand side, and this is a factor of that, so you will have, so we're getting there somewhere. Now, here you got a product. Right? And and you got a prime number here. You see, you would have known until 2019 that this is a prime number. You'll have to know something about the year in which you're writing. Like today, this year is 2024, right? You should know the factors of this. This is actually, if you work it out, it's 2 cubed times 11 times 23. So 23 is a factor of this. And another interesting fact is that next year will be 2025, and that's a square year. It's 45 squared. So next year is a square year, which doesn't occur very frequently. The last square year was 44 squared. 40 squared is 4 squared is 1936, 1936. And this is a long time ago. Probably your grandparents were born around this time, or born around this time. So next year is quite a significant year. Anyway, that's just as an aside. Usually in these competitions, they want you to also know some properties of the year in which you are in. And I've just told you 1 or 2 things about this. Now, there's another interesting thing about prime numbers. When you got a prime number, let's call it P, is a factor of a product, then it necessarily follows that the prime number is a factor of each of those. It's a factor of A or it's a factor of B. This always works. Just this, if P is prime. So a prime number, if it's a factor of a product, it's always going to be a factor of one of these. So you got the 3 is going to be a factor of n plus 1, or 3 is a factor of n plus 19, right? Or you got 673 is a factor of n plus 1, or 673 is a factor of n plus 19. Right. So there are various possibilities here. But let's look, we're looking for the smallest n which will satisfy this. And let's look at this thing here. 673 is a factor of n plus 1. That means that n plus, what are the possibilities for n plus 1? So n plus 1 is equal to, if it's going to be a multiple of 673, it's going to be 673 or another multiple. The next multiple is 1346. And the next one is 2019. This is 673 times 3. But you want the smallest integer n. So n will be equal to this minus 1, this minus 1, this minus 1. But if you want it to be as small as possible, you'd rather do that, because then we're subtracting 19. So let's say n plus 19 is 673 or 1349 or 2019. Right. So therefore you'll have that n. Right. Now you also want n plus 19 times n plus 1 must be a multiple of 3. Right? Because we saw that this thing here is a multiple of 3. Now at the moment now, if you take n plus 19 is that, so let's just see. So n plus 1 is 18 less than this. So this is 655, I think. So 18 less than this is 1331, and this is 2001. Right. So n plus 1 is going to be this. You'll notice that this is, when you add this thing, you get 16. So this is not a multiple of 3. When you add this, you get 8. It's not a multiple of 3. But when you add this, that is a multiple of 3. So therefore, the one that we're looking for is this last one. So therefore, n plus 19 is 2019. N plus 1 is 2001. So n is 2000. That's the smallest. That's the first multiple of 3 that you get. Okay, it's a little bit tricky, but there are 2 important facts here, which I've told you. If a prime number divides a product, then the prime number must divide one of the 2. It doesn't happen with other things. Like, for instance, 6 divides 12. That's not a prime number. 6 is not a prime number. And prime number 12 is 3 times 4. And 6 is neither a factor of 3 or a factor of 4. So you can't make that conclusion for numbers which are composite. But for prime numbers, you can always guarantee that this is a factor of the first one or the second one. But if you've got a whole lot of numbers here, products, P must divide at least one of them. Okay, so that I'm sure many of you would have been able to solve that problem. Now let's just get on to the next one. So the next problem is, oh, this looks frightening. All right, so let me read this thing. S is a set. So these questions evidently occurred in 2019. So if you go and look at the 2019 team paper, you'll probably find these questions. Now, why are the team questions difficult? Because there are 10 people who will tackle this problem, each of these problems, right? They might work together or they might work separately or whatever it is, they'll work out some kind of a strategy to optimize to get the highest number of marks. But if 10 people are working on this simultaneously, you'll have a lot of input and you'll get, somehow you can get to the answer. All right, now you got S is a set of 2019 numbers, or you got the numbers S are of this form here, and N varies. N could be 0 or 1 or 2. There are 2019 values for N, and therefore there are 2019 such numbers, because each time you put in a number, you get an answer. Like, for instance, if I put n equals 0, the very first one, a is 0, 2 to the 0 is 1. You're putting n equals 0 there. So that's 3 squared. And n equals 0 here. So that's 5 squared. Okay, so that's 35. So A0 is that, for example. And A1 will also, you can work it out. And A1 turns out to be quite a big number. These are exponents, so these numbers can be extremely large. Like if you take n equals 2018, and you imagine you got 5 to the power of some huge number. And then, okay, so these are the ANs, right? So you can work out A1 and A2 and so on. Right. Now the question is, what is the greatest common divisor of all the numbers in S? Right? So you need to have a number which is a factor of all these 2019 numbers. It's a divisor, a common divisor. Right? So it must be a factor of all the numbers, but you want it to be as large as possible. Right? Now, one of the numbers which factors all these numbers is 1. Right? 1 goes into everything. But evidently, this problem, the answer would not be 1. Otherwise, they wouldn't ask this question. But whatever it is, you have to look for the largest number that goes into all of these. So that's going to be quite a tricky business. Okay, so what I'm going to do is, I know that A0 is 35, and that helps me a bit, because the number that you're looking for is actually a factor of every one of them. So in particular, you can zoom in on what the possible values of the HCF is. Greatest common divisor is the same as highest common factor, HCF. They shouldn't use the word greatest common, they should call it highest common factor. Most people wouldn't understand what that means. So HCF, the highest common factor. So it's going to be a common factor. So let's call this thing X. So X is equal to, it's going to be a factor of every one of them. In particular, it's going to be a factor of this. And this one here, you can see is 5 times 7. It's got only 4 factors. So the X is going to be one of these numbers, right? So which one? All right, now this can be quite difficult. There's a certain strategy that you're going to use to do this because this looks very, very complicated. And the strategy that we're going to use is that we are going to subtract consecutive numbers in the sequence. The sequence is A0, A1, A2, A3, and so on. Right? And I'm going to subtract consecutive numbers. In other words, AN, and the next one is AN plus 1. I'm going to subtract it, and you will see later on why this is so. It's very nice strategy. So let's work out AN plus 1 minus AN. All right. So what is AN plus 1? Now, that's a little bit nasty because AN is this. So, or A subscript N. I just call it AN. It's A subscript N. Some people call it A sub N. So I have to put N plus 1. N is sitting here. I have to put N plus 1 wherever N occurs. So you got 2 to the power of 3 into N plus 1. I'm going to write that down straight away. 3 into N plus 1 is 3N plus 3. Plus 3 to the power of, I'm going to replace this by N plus 1. So what do I have? 6 into N plus 1. That gives you 6N plus 6. And there's a plus 2 there. Okay. And here I do the same thing. You got 6N plus 2 again there. So this is 6N plus 8. Let me just put these two things together as 8. 6 plus 2 is 8. So this is now AN plus 1, right? And AN is, it's already there. It's 2 to the power of 3N. Let me do it like this to make it a little bit easier. I'm going to put 2 to the power of 3N underneath this, plus 3 to the power of 6N, plus 2, plus 5 to the power of 6N plus 2. And I'm going to subtract these two things. That is AN plus 1 minus AN. Now, this minus this. So what have we got? 2 to the power of 3N plus 3 minus 2 to the power of 3N. Now, this is, when you do indices, you will know that you can factorize this because this is 2 to the 3N multiplied by 2 cubed. And this is 2 to the 3N. So 2 to the power of 3N is a common factor, right? It's a common factor. It goes into this 2 cubed times minus 1. 2 to the 3N, you can take it out as a common factor. And 2 cubed minus 1 is 7. 8 minus 1. So it's this. So I'll put a 7 in front. So it's 7 times 2 to the 3. And so when you subtract these two, you're going to get 7 times 2 to the power of 3N. Now, like that, you can do the same thing here. And I'd rather do it. If you take the next pair, this time you got 5 to the power of 6N plus 8. Or 3 to the power of 6N plus 8. 6n plus 8 minus 3 to the power of 6n plus 2. And this time, you'll see that 3 to the power of 6n plus 2, that's the smaller of these two, is a factor. And then if you take out 3 to the 6n plus 2, here you have 3 to the power of 8. Oh, no, wait a minute. 3 to the power of 6. I'm taking out 6n plus 2 minus 1. Okay, so that's 3 to the power of 6n plus 2. And 3 to the power of 6 is 720. 9 minus 1 is 728. Okay, so this is plus 728 multiplied by 3 to the power of 6n plus 2. And if you do the same thing here, this is 6n plus 2. You'll get 5 to the power of 6n plus 2 into, and you would have had 5 to the 6th minus 1, just as you had there. Now, you can actually factorize this. This is a difference of 2 squares. It's 5 cubed minus 1 into 5 cubed plus 1. So instead of working out this big number, I can factorize it straight away. 5 cubed minus 1 is 125 minus 1. And here 5 cubed plus 1 is 126. So here you have 124 times 126. Now this is the interesting thing. I'm looking to factorize this. I'm looking for a common factor. And you'll see 7, this is 7. This is 7 goes into this exactly. It's 104, 7 times 104. So 7 can be taken out from here. And as far as this is concerned, this product, 7 doesn't go in here, but 7, this is 7 times 18. Right? So you will see that this is a multiple of 7, this is a multiple of 7, and this is a multiple of 7. So you've got, this is 7 times something. I'm going to call it 7 times A subscript n. All right? It is 7 times something because 7 goes into every one of these things and it comes out as a common factor. So what have we got? We found that 7 is a factor of every one of these differences, which is quite a powerful statement. Every one. So it looks very much like the answer to our question is 7. So let's call this 7 A subscript n, like that. Now I want to prove now that 7 is a factor of all the ANs. I only know it's a factor of the difference, but is it a factor of every AN? So this is a very important question. So is it true that 7 is a factor of all the ANs for every n equals 0, 1, 2, all the way up to 2080? Is that true? We only know it's a factor of the difference at the moment. All right, so let's analyze that. And I'm going to write down all these equations. You see, I've got 7 an minus 1, an plus 1 minus an is 7an. I'm going to substitute all these values. All these 2019 values. Well, actually, not to the 2019, I'll only go up to n. So if I put n equals 0, I will have a1 minus a0, n equals 0, is equal to 7a subscript 0. See, it's a multiple of 7. And then if I put n equals 1, I have a2 minus a1 is 7a1. If I put n equals 2, I have a3 minus a2, n equals 2. 2 plus 1 is 7a2. And I'll go up to an because I wanted to know whether 7 is a factor of an. That's my question. So I'll go up to an minus 1 is 7 an minus 1. All right. Now now you will see why this difference was so important. Because I can add all these things. When I add all these things, something quite remarkable happens. The A1 minus A1 cancels off. A2 minus A2 will cancel. And this guy here will disappear with that previous one there. So there are only two survivors when you add all these numbers up. The survivors being AN and A0. And A0 we already worked out was 35. And that is, we're adding all these. So this is going to be 7 into the sum of all these. I'll just put dot, dot, dot to show that we're adding all these. Now you can see AN, if you bring 35 to that side, you got a multiple of 7, and you got a multiple of 7 here also. So if you got two multiples of 7, the AN is also a multiple of 7. So in other words, 7 is a common factor. Now the question is it the highest common factor? Okay, we said, so 7 is a common factor, but the highest common factor, is it, in other words, is it not possible that 35 also goes into every one of them? We know that 35 goes into the first one, right? Now, so is it possible that 35 is a factor of AN for every n? Is that true? Okay, we know it's a factor of the first one, but let's try the A1. Okay, let's try, is 35 a factor of A1? Now, what is A1? Okay, let me just go back. So the final question is, I'm going to show that 35 is not a factor of A1. Okay, the way to do that is, if it is a factor of A1, that means 5 is a factor of A1. That's 5 times 7. And for a number to be a multiple of 5, it must end in 5. Okay, so I want to look at A1 and see whether it ends in 5. That is a question. I'll repeat that. If 35 is a factor of A1, then 5 is a factor of A1. And if 5 is a factor of A1, its last digit must be 5 or 0. Right? So let me just check to see what the last digit of A1 is. Is it 5 or 0? If it is 5 or 0, then 35 is a possibility. Right? Now, let's work out the last digit. A1 is 2 cubed plus n equals 1, you see. And this is 3 to the 8. And this is n equals 1, this is 5 to the 8. So the question is n a multiple, A1, is it a multiple of 5? Is it a multiple of 5? Okay, you already got a multiple of 5 here. So the question is this a multiple of 5? Okay, so 2 cubed is 8. And 3 to the 8, when you work out 3, you can work out 3 squared. Just work out the last digit. You'll see the last digit is of 3 to the 8 is 1. The last digit of these. So the last digit of this is 9, and this ends in 5. So A1 ends in 4. So it's negative. If it ends in 4, 35 cannot be a factor of A1. So therefore, the highest common factor is 7. It took a long time. As I told you, these questions can be quite demanding. But I went very fast on this, but there are a lot of fundamental things about numbers, how you work with natural numbers, right? And I've given you a strategy, like for instance, if you want to show that something is true for every value of n, it's nice to take differences of consecutive numbers and add them, and that helps a great deal. Okay, so we get on to the next
Prof,
one.
Prof,
Yes, yes.
No, there was a comment on this question. Can you check that? It's just a comment, not a question.
Yeah, okay, thank you for that.
Partly.
If you found the common factor of A0 and A1, would that not suffice? Because 7 would be the greatest factor between the two. Now that's an interesting possibility. Yeah, Caitlin, that's good. That's a good observation. It's a pity I didn't see your comment earlier on. Yeah, if we can see. No, okay. You know what the problem is? You're going to go to A1 is going to be a very large number. All right, but it doesn't really matter. All you have to do is to find out which is the highest common factor and try to see 7 or 35 or 5 goes into that number. Certainly 35 and 5 doesn't go into that. You can try 7 and oh yeah, you know what happened there? Caitlin, you would have proven that 7 is a factor of those two. That's all. But you still don't know whether 7 is a factor of the third one. You see? Caitlin, do you understand? You can prove that 7 is a factor of A0 and A1. The highest common factor of those two will be 7. But that doesn't mean that 7 is the highest common factor of all 2019. You need to show that 7 is a factor of every one of them, not just these two. Do you understand, Caitlin? But it's a good question. Okay. The highest common factor of you got 2019 numbers. You have to find a number which is a factor of every one of them. All right. Now let's just get to the Thanks for pointing that out, David. Okay, now we go to question 4. Let Fn be equal to n squared plus 3n plus 2. Compute the following product in the lowest terms. So you can substitute these different numbers, try them out, put n equals 1 and get a number here, n equals 2, get a number here. With this Fn, f of 1, you have to substitute, f of 2, substitute. And when you substitute 2019, you can get a nasty piece of work there at the bottom. And then you have to multiply all this stuff. And so just substitution like that doesn't help you too much. Let's see whether we can get a formula for the general term. The general term looks like 1 minus, every one of them got 1 minus 2 over, 1 minus 2 over. And then at the bottom, you got f of, let's call it f of n. Right? Then I can substitute n equals 1, 2, and 3 in any one of them. Let's get a formula for this. So this is 1 minus 2 over n squared plus 3n plus 2. Right? And the common denominator is n squared plus 3n plus 2. Here you have n squared plus 3n plus 2 minus 2. Okay, the 2's cancel off and you have n squared plus 3n. Let me factorize that. With n into n plus 3, n squared plus 3n. At the bottom, you can factorize this also. N squared plus 3n plus 2 is n plus 1 times n plus 2. All right. So you got each term here is looking like this. Now this is very interesting because you got 4 consecutive numbers here. n plus 1, n plus 2, n plus 3. So you can write down any one of these very quickly. For instance, 1 minus 2 over f of 56 is 56. The next one is below it, 57. The next one is next to it, 58. The next one goes to the top. So you can work out this very quickly without having to substitute 56 in that rather or 58 or whatever it was in this rather complicated formula. All right. So now I'm going to actually use this formula to calculate what this is. So let me rub all these things out and just go to the formula. Oh, that one. Yeah, I messed that thing up. Okay. Okay, I can't get rid of that. So let's see, what is this equal to? Let's work out the first one. I'm going to put a long line here. And all these things are being multiplied. So for the first one, n equals 1. So I'll start there, 1, 2 times 3 times 4. Right, as I saw earlier on. Okay, so that takes care of this first one. The second one, we are multiplying it. So I can put, now n is equal to 2. So I'll have 2 times 3 times 4 times 5. Like that. And the next one, you'll have 3 times 4 times 5 times 6. See, you just go n plus 1, n plus 2, n plus 3. Just keep going around in a circle like this. And the last one will be 2019. Yeah, n is 2019, 2020, 2021, 2022. Okay. I'm going to put a straight line here. It doesn't look very nice. Okay. So all these things, you got numerator has got product of a number of numbers there in the denominator. And evidently you should be able to cancel many of these, but it looks very complicated. Well, how do I actually simplify this? That will be quite a challenge. Now, so there are certain tricks. You see these factorials. Let me talk about factorials for the moment. 1 times 2 times 3 times 4. I think by now you should know this is n factorial. If you take all the numbers from 1 going up to n and multiply them, you've got a simple term, which is n factorial. Okay? So there are some very interesting things. Like, for instance, if I've got n plus 1, say n plus 2 factorial divided by n factorial, and this is 1 times 2 times 3 all the way up to n plus 2. And here you got 1 plus 2 times 3 all the way up to n. So you can see you're canceling off a lot of things. And n, it occurred earlier on. The one just before this is n plus 1. And the one before that is n. So the n's here would have cancelled off with this. And you are left with only n plus 1 times n plus 2. So if you got two numbers which are very close to each other, and you got factorials, then this thing simplifies very nicely, right? So let's see whether we can write these as factorials. Now, you got 1 times 2, the alternate numbers, 1 times 2 times 3, right? It goes all the way up to 2019. So you got 1 times 2 times 3 all the way up to 2019. And those are the alternate numbers. The other alternate numbers are 4 times 5 times 6. All the way up to 2022. Right? And then you're dividing the denominator is, well, again, alternate, 2 times 3 times, oops, 2 times 3 times 4, and so on, up to 2020. And the other one will be 3 times 4 times 5 times 6, all the way up to 2021. See? So now, if you look at this now, you'll see most of these cancel, right? All the way right up to 2019, they all cancel. The denominator here will be just 2020. See? The one just before this was 2019. So 1 doesn't affect anything. 1. So the 2's cancel, 3's cancel, and so on. So the only survivor at the bottom is 2020. And here, let me put a 2021 here, multiplied by 2022, right? These are consecutive numbers, so the 2021 would have occurred. So you got those cancel. The 3 is still sitting around there. So this is times 3. And here, the numerator is 2022. So that is the product. Another horrible looking thing, but it's such a nice answer. By the way, you can simplify this to get 337, because this is 6 times 337. Here you have 6 times 10, 10. That is the simplest way in which you can write this thing. All right. So this is a nice example where you get a general formula for that, and then you use that general formula to simplify this thing. So that's a good trick. Right? Don't try to work out each one of them and multiply 2019 numbers now. Right? That'll be, your calculator and the biggest computer in the world will crash. All right, so you've got the next question. See, these are all searching problems, but they are very interesting. There are many problems of these types that occur in Olympiads. But as I said, these Olympiad problems you can never train for Olympiads. And all you know is you get yourself comfortable. You feel, well, I think I can do something, rather than go, straight into the lion's den. You can see most of the mathematics we are using here is not very complicated mathematics, but the thinking involved is what is the difficult part. Now look, you've got in 2018, Caesar bought a smartphone whose price was a 4-digit number. Okay, so maybe the price was 3496. All right, so suppose that was the price. Right, that is in 2019. When he went back there, that's 2018. And when he went back to the next year, the price went up by 20%. Right. So the next year is 120% of 3496. Right? He noticed that the price had increased by 20%. But he noticed also the price is made up of the same 4 digits as the original price. Right? So I just took a random number here, but it says the same 4 digits of the original price, but written in the reverse order. In other words, I got 3496. When I work this thing out, I get 6943. Right? 120% of that is the same number written in reverse order. Now, of course, this is not true, but now you want to. Question is, what is the value? What are the possible values with a smartphone in 2018? Right, the original price. What are the possible values? Okay, so evidently you got an equation here. You got an equation. So and I have to write this number in reverse order. So I need to know what the digits are. So you'll say let n be this 4-digit number. But suppose the digits are A, B, C, and D. Right, that's your 4-digit number. So A is 3, B is 4, C is 9, and D is 6 in our example. You can write this thing in terms of A, B, C, and D, because this is 3,000 plus 400 plus 90 plus 6. And 3,000 is just 3 times 1,000, 4 times 100, 9 times 10 plus 6. So you have, this is actually 1,000A, 1,000A plus 100B. That's why they call this the hundredths unit. And this is a tens unit, so it's 10C plus D. So my problem is to find all the possible values for A, B, C, and D. All right. So I've got a starting point. Let n be equal to that. I've got 4 unknowns. So what information are we given? We're given 120% of that number. Now 120% is 120 over 100, and that is 6 over 5. So when you multiply this number by 6 over 5, times this thing here, you're going to get what? You're going to get the same number written. You're going to get DCBA. Right? Let me just not take any shortcuts here. So 6 over 5 times the original one, 1000A plus 100B plus 10C plus D is equal to the same number but written in reverse. So you're going to get DCBA. So what is that? That's 1000D plus 100B. We're writing it back. Sorry, 100C. We're writing it backwards. Plus 10B plus A. So that's the equation you have. You have just only one equation, 4 unknowns. So it's quite a challenge now to find out what these numbers are. And listen very carefully to see the logic that we can use. We can use nice, beautiful logic to finally get down to the answer. All right, so at a starting point, I can just multiply both sides by 5, and you have 6,000A plus 600B plus 60C plus 6D, right? And multiply this by 5, and 5,000D plus 500C plus 50B plus 5A. Okay. So okay, when you take out all the brackets, this is what you get. Let's get all the A's to one side. There's an A here, and there's so it's 6,000 minus 5. That's 5,995. You should be able to work that out in your head. 6,000 minus 5. So the A's are out. Now let's take the B's now. 600B minus 50B. So that's 550B. 600 minus 50. Then you got 60C minus 500C. Now you're getting a negative here. I don't like to work with negatives. Let me just put this equal sign here and bring the 60 on this side. So you get 500C minus 60C. 500 minus 60 is 440. 500 minus 60. And then you got 5,000D minus 6D is 5,000 minus 6 is 4,994. D. All right. Now you got all astronomical numbers here. But you'll see I got 550, 440, and it looks as if 11 goes into this thing. And in fact, 11 does suddenly go into this. You see, 5 plus 9 is 14, 9 plus 5 is 14. 4 plus 9 is 13, 9 plus 4 is 13. The rule of divisibility, if you use it, you will see 11 goes into this, and you will see it goes into it 545. A plus 50B. I'm dividing by 11. 40C. 11 goes into that. Now this thing here is 454D if you divide it by 11. Okay, now you can see the monster is now being tamed. That horrible looking thing there is looking a little bit more dignified here. Now comes the observation. You see, I've got 545, I've got 50, I've got 40. There's a nice common thing here. You can see 5 is a multiple of all these. If I take the 40C to that side, you can take out 5 as a factor. In other words, 5 is a factor of this one here. See, if I take it out, so 5 is a factor of this. So what does it mean? You got 454 here. And for 5 to be a factor of this, the only way this can happen is that if D is either 0 or 5. Right? So now straight away, you've got, we zoned in on what the possible value for D is, which is very nice. Let me just create some space here. So from this last thing here, it means that D is either 0 or 5. I'm going to put a thing like this because that's very important. I've got a value for D. Okay, so now the question is, what is D? Is D 0 or 5? Okay, let's try 0. If D equals 0, let's go to our equation. You got 545A plus 50B. I'll put D equals 0 there. So you get 40C. Right? Is equal to 40C. And that means, well, I can divide by 5 right throughout now. Go to 109A plus 10B equals 8C. If I divide by 5. Now, there's a little thing which we have to observe here. This thing was a 4-digit number, which means that A is greater or equal to 1. Because your original price is a 4-digit number. You can't have a 0 there. So what does this mean? It means this thing here, the left-hand side, this is greater or equal to 1. And this is a digit. So this whole thing here is greater or equal to 109 times 1. This may be 0. But whatever it is, both are positive numbers. And this is greater or equal to 1. On the right-hand side, the largest value you can have for C is a digit, is 9. And that's less than or equal to 8 times 9, which is 72. So you can't have this. This is impossible. The left-hand side is always greater or equal to 9, 109, and the right-hand side is always less than or equal to 72. So it's impossible. So this D equals 0 doesn't work. It'll give you no solutions. All right. So let's now go to D equals 5. I'm going to rub this thing out. So now we have the D is equal to 5. Now that's very nice. Oh, I found one value for A, B, C, D. It's 5. Okay, now if you, as before, we substitute D equal to 5, and you've got 545A. This is your master equation, plus 50B equals 40C, and D equals 5 here. So that's plus 2,000. When you multiply that by 5, it's 2270. Multiplying by 5 is really halving the number. 227, the 0 in it. Okay, now 5 goes into all of these. So once again, you get 109A plus 10B is equal to, dividing by 5, 8C plus 454. You divide this by 5. Okay, now let's see what this means. Okay, now this A here, you see, this is 8 times 109. So the A can't be too big. You got a 454 here. Right, so can you have A equal to, A can't be 5 or more. Let's see by inspection, because this will be 545, and this, the largest possible value this can have is 454 plus 72, which is 526. All right. So this thing here is less than 526, because the largest possible value for C is 9. So A equals 5 doesn't work, because, so you could have A equal to 4. Okay. So so you suppose you make A equal to 4, but what about A equals 3? Now, A equals 3 doesn't work also, right? I want you to check this thing out. A equals 3, 2, 1. They don't work. I'm not going to do it. It's quite time consuming. But A equals 4 works. So let's put A equals 4. You get 436 plus 10B equals 8C plus 454. All right. So then you have yeah, you can put, so you can get 10B is equal to 8C plus, let's take the 436 to the other side, with 18. And that's a nice small number. 454 minus 436 is 18. So you have 5B is equal to 4C plus 9. Oh, you see, I got such a lovely, simple equation from all these thousands. Right. So B is a digit, C is a digit. So let's see. Now it's easy, because we can try different values for C and D, and we got A is equal to 4, by the way. Right? I said they don't work, so A equals 4. So we got A and D, and the only thing is we need to calculate A and C. And if you try the digits from 0 to 9, you will see that only C equals 4 and C equals 9 works, right? None of the other works because you need to get a multiple of 5, you see? This is a multiple of 5. So how do you get a multiple of 5? When you put C equals 4, you get 16 plus 9. And you put C equals 9, you get 36 plus 9. So C equals 4 or 9. And then the B will be 5. And C is 9. There is so 5 or 9. Okay. So you'll have BC is 5, 4. So the answer is A is 4. Now B is 5 and 4 go together, right? And we already know that D is 5. So answer is that, or see, the number you're looking for is A, B, C, D. So that's what I'm writing now. A is 4 and B could be 9. But when B is 9, then C is 9. And D is still 4. So you get two answers. See? And if you, so our calculations lead to just two numbers. The cell phone either costs 4,545 or 4,994. And if you actually calculate this thing here, you will see, if you work out 120% of 4545, you'll get 5454, which is that in reverse. So you can check it out. So that's the answer to the problem. So it's a very nice problem. Again, you're working with the whole numbers and you got digits, and you have to make estimations and so on. So this is interesting problems. See, have to think of different possibilities. All right, so that takes care of that one. Is question 5. 1, 2, 3, 4, 5. So we're going to question 6 now. Now, question 6. I already spoken about P factorial, right? If you read this as P factorial, and you guys should know about this by now. It's, as I said earlier on, is 1 times 2 times 3, all the way up to P, right? Now, P is a prime number. Determine the largest possible integer value of n, so that P factorial to the power of n divides P squared factorial. Now, so what have you got? You've got P factorial to the power of n, and that is P factorial times P factorial times P factorial n times. And you want that to be a factor, divides a factor of, now P squared factorial is 1, 2, 3, all the way up to P squared, right? And you want to know what is the largest possible value of n for this to work. Okay. Now, you can see P factorial is 1 times 2 times 3 up to P. There are P factors here. And here you got P factors, P factors. So it gives us an idea that let's break this product up into groups of P. Okay, Okay. I'm going to put all these numbers on the number line. And I'm going to write down all the numbers, 1, 2, all the way up to P. Now, that's a group of P. The next one will be P plus 1, going all the way up to 2P. And then next one, you go 3P, that's another group of P. And then it's going all the way up to P squared, right? We're looking at this thing here, the right-hand quantity. The one just before that would have been P minus 1 times P. 3P, 2P, 3P, and here you've got P minus 1 times P, and the next one will be P squared. Okay, now, we're multiplying all these guys, right? So, in particular, let me just look at the P. P occurs only once in this set here. From 1 up to P, P occurs only once. And likewise, P only occurs once here. So P occurs once here, and so on. So how many times does P occur in this? What is this equal to? It's equal to P to what power? Because when you multiply all these things out, you will have, let's just focus on the multiples of P. So you have P occurs here, but only once in the group. So there are P groups altogether, P groups of P, to give P squared of P numbers. And P occurs exactly once in each of those groups, except the last one. So you'll have P times P groups, but the last one has got a square in it. See? So it means now that this is P to the power of P plus 1. Because the P plus 1 P is in this. Right? Only one which has got, which is more than a multiple of P is the last one. Okay, so P to the P plus 1 goes into this. Is a factor of P squared factorial. And the P plus 1 cannot be improved. Why? Well, by improve, I mean you can't make it larger because there's only exactly one P in each one of them, right? And P plus 1 is the largest power. That divides P squared factorial. Because it only occurs once in each one of them. If there's any higher power, it means somewhere along the way it'll occur more than once, and that's not true. Okay, so here the question is P factorial, what is the largest possible integer value of n for this to happen? So it looks as if the answer is P plus 1. Okay, the answer is possibly P plus 1. Now you have to ask why possibly, what's going on here? See, you see, what you have here on the left-hand side is 1 times 2 times 3 all the way up to P. So let me just write this down. Oh, okay. Yeah, actually, what you have is the following. The left-hand side, we can simplify the left-hand side. Because P factorial to the power of n is that each of these P factorial is 1 to the power of n times 2 to the power of n times 3 to the power of n, all the way up to p to the power of n. That's what this is equal to, because you're raising the entire thing to the power of n. All right, so we saw that n equals p plus 1 is a possibility, but you want this to be a factor of this. So you want to know whether I can have n equals p plus 1 for all the others, right? For p, the last number you can have is p plus 1. Is it true that, say, for instance, say 2 to the power of p plus 1, is that a factor of p squared factorial? Right? Or any one of these? I'm not going to go into the details of that, but if you look at 2 now, right, and you take, how many times does 2 occur here? 2 occurs once, more than once maybe. Yeah, to more than once, because you got a smaller number, right? So the number of 2's that occur in this product is, and somewhere along the line you got a 2 squared as well in this, because 2 squared is smaller than p squared. Or you've also got a 3 squared here, all the way up to p minus 1 squared. They are all part of the product of this. So 2 occurs at least p plus 1 times. The same thing with the 3. P occurs exactly p plus 1 times, but 2 occurs at least, because there are many other 2's here. So each of these 2 occur at least p plus 1 times. So therefore, we can say that the largest possible value is n. Think about this. It's a I found this, I have to admit, although I'm sitting here like a big fundi, making it look as if I know all the answers to these questions, the fact of the matter is, I take a long time to work these things out. Right? The webpage, South African Maths Foundation, it just gives you the answers. It doesn't give you the processes of how to get to the answer. So I had to work out all these things by myself. It took a long time. Okay, now let's just go on to the next question. I think we don't have too much of time. Let me see. I'll just choose a question. Maybe I've got time for one more question. Oh, all right. No, I'm not going to do this. This is a little bit difficult. Okay, let's try this. This wouldn't take so long. Okay, find all primes A, B, and C such that A is less than or equal to B, less than or equal to C. So these are all primes. They could be equal. I could have had 2, 2, 2, or 3, 3, 3, or 11, 11, 11. Right? It could be equal, such that you've got this inequality here. I somehow don't like to work with greater than. I prefer working with less than. So ABC is less than AB plus BC plus CA. All right, now I've got 3 unknowns, not even an equation. I've got an inequality. But what we have is these are prime numbers. So how do you solve this problem? All right, let me just see. ABC is less than this. Let me see whether this is less than or equal to, knowing this, I got B is less than C, and A is also less than C. So let's look at A. A is less than C, so AB is less than CB. And BC is equal to itself. And here, CA. So A is smaller than B. So this spot here is also less than BC. Because A is less than or equal to B, you see. So when you multiply on both sides by C, you have the CA is less than CB. So I've got all these three things are equal here. 3BC. So now you have that ABC is less than 3BC, less than. So that means that therefore A is less than 3. Okay, so that little observation that when you put it down like this, that you can make all of these the same. See, working with inequalities, namely BC. You would not have been able to put ACs here or CAs. The only thing you could have put is BC, right? As we saw. So A is less than 3 because BC will cancel off. But A is a prime number. And there's only one prime number less than 3. So A is equal to 2. So we calculate the value for A. All right, so now, knowing that, let's just simplify this and put your value for A. You got A is 2, so you got AB is 2B. And AC is 2C. A is 2. And you've got BC. 2BC is less than that. A is 2. 2BC is less than this. Okay, so the BC is, I can bring it to the other side. So you got the BC is less than 2B plus 2C. All right. Well, I can bring B or C to the other side. Let's take B to the other side. And you have BC minus 2B is less than 2C. And then you got B into C minus 2 is less than 2C. I remember these are all prime numbers. And all these numbers are greater or equal to 2 because we said A is 2. So, anyway, they are prime numbers. So all prime numbers are greater or equal to 2. So there's nothing any special about that. Okay, now we got this. Now, the way to do this, let's see now, we have to try different values for C. I'll try different values for C. Make C equal to, say C equal to 2. Let's put C equal to 2. Now A is 2 and C is equal to 2. That means B is also equal to 2. Right? Because this is 2 and there is 2. B is in between. It has to be 2. So the question is ABC, let's put this as a triple like this. Is this a solution for all? We had A is 2, B is 2. Is it a solution? Well, to check to see whether it's a solution, try it out here, right? 2, 2, 2. The left-hand side will be is 8. And the right-hand side, AB plus BC. So you got 2 times 2, 2 times 2 times, you got 3 4s. The right-hand side is 12. And 8 is smaller than 12. So this is a solution. So one of the solutions is 2, 2, 2. How did I get that? I put C equal to 2. So let's take other values for C. Let's try C equal to 3. And see what happens. If C is equal to 3, then you will have ABC. A is 2, C is 3. And this is a prime number in between. I can put 2 or B has to be less than or equal to C. So the only two possibilities here, right? Because A is 2 and C is 3. The only prime numbers between 2 and 3 are 2 and 3. All right. And you'll see that this works and that works also. So you have 2, 2, 3 is the solution, and 2, 3, 3 is the solution. You can try it. You'll see when you substitute, it works. Okay, so let's try C equal to 4. Right, if you've got C equal to 4, then you have so what are the possibilities? You've got A, B, C. Oh, C can't be 4. It's a prime number. All right. Okay, so C equals 4 is out. So the next one is C is equal to 5. Right. So let's see what happens. When C is equal to 5, then right, let's put C equal to 5 in this one here. So if C is equal to 5, you got C is 5 minus 2, you got 3B. C is equal to 5, you use your 10 here. So 3B is less than 10. And the primes which are less than 10 are 3. 3 times 3 is less than 10, and 3 times 2 is less than 10. So you'll have that ABC is equal to 2, 2, 5, and 2, 3, 5. Both of these work because B is either 2 or 3. You can try them, substitute, and you'll see it works. So it looks as if everything works. But what happens now when C is greater than 5? C is greater than 5. What happens is that then you will have, let's have a look at this. Then you'll have 2, oh, yeah, C is greater than 5. Then, yeah, then you have this kind of a thing here. You see this B into C minus 2, this is the hard part. B into C minus 2 is less than 2C. And B is less than 2C over C minus 2. C is greater than 5, so that is positive. We can divide an inequality by a positive quantity. Whenever you're dividing or multiplying an inequality, you must make sure it's positive. So C greater than 5 is positive. Now I have to make an adjustment here. This is 2 into C minus 2 plus 4. I want to get a C minus 2 at the top there. 2C minus 4 plus 4 is 2C. So when I put this, then I'm adding minus 4. I'm not allowed to do that. So I add 4 to balance this thing out. And then the right-hand side then becomes this over this, which is 2 plus 4 over C minus 2. Now C is greater than 5, you see. So if C is greater than 5, this becomes a fraction, right? So this is less than 3. This is less than 3. So the only B which is less than 3 is B equals 2. Right? So then you have 2, 2, and C. And it doesn't matter. No matter which C you have, which is greater than 5, is going to work. All right. Now let's, where C is any prime number greater or equal to 3. We've already seen the 2 to 3 and we've seen 2 to 5. But this last number can be any prime number. Right? And to check that out, This part here is smaller than 1. So therefore, the whole thing is less than 3. This problem got a lot of inequalities in it. So now if A and B are both equal to 2, let's see what happens. ABC is equal to 4C. If A and B are both equal to 2. On the right-hand side, you got AB plus BC plus CA. A and B are both equal to 2. So you'll have 4. And this B is 2. So you have 2C. And A is 2. 2C. And that gives you 4 plus 4C. And yes, ABC is certainly less than that because this is 4C plus 4, you see. So no matter what C is, ABC will always be less than 4C plus 4 than this quantity. So regardless of whatever prime you use here, you'll have that inequality. So there are actually infinitely many solutions to this equation, right? And these are the various solutions. Okay, so that takes care of that. Yeah, and then there's still a couple of problems which I've got here, but we don't have time for that. Look, there's one geometry problem here. We've done no geometry at all. Because in these team questions, you don't have geometry questions. How do you get one answer for geometry? In the end, you need to have one particular answer. Sometimes you might say, what is the area? Okay, we've done things like that. Calculate the area, then you get a single answer. But generally, if it's a rider, if it's a problem where you have to prove something, you can't ask that in a team question. But I thought that just for your interest, I look at one geometry problem, which is a very interesting problem and not easy to solve. And it looks very easy. So what you've got here is you've got an isosceles triangle. You can see those two are the same. And you've got a point inside the triangle such that this is equal to that. So you got another isosceles triangle here. And also that this point makes an angle of 30 degrees with AC. So that's the information. The information is in the picture, everything here. The question is, what is this angle? That's the question. What is that angle? ADB, the angle between the two dotted lines. Now, you can try it. It's quite a difficult problem. In fact, it's a very difficult problem. So I'm going to do it to show you how deep geometry can get. I'm going to use trigonometry to solve this problem. All right? And most of the trigonometry you have seen in your schoolwork. And as it stands, when you do this problem here, you can't solve this problem. You have to have a construction in this. Okay, so let's just remove the theta. This theta is supposed to be there. Okay, so to solve this problem, remember the question is what is that? Right? I'm going to do it step by step, and hopefully you can follow this thing. Now this is the strategy. I'm going to give a name to that angle. I'm going to call angle B. I'm going to call it theta. Right. I'm just going to give a name to it. I don't know what it is. This small angle here between the dotted line, that is 30 degrees. Okay. So that angle is theta. And So the strategy is, I'm going to find AC in terms of theta. This one here. Now that we can do, right? Why can we do that? Let's just isolate this thing. Oh, by the way, all these equal lines, just to make life easier, we can call them all equal to 1. No harm, because there are no numbers given, so you can put any number you like. So this is theta. Now you can calculate this if you use the cosine formula. But when you got isosceles triangle, you don't have to use the cosine formula. There's a very simple way of doing it. I don't know why teachers don't teach this. Isosceles triangle, all you do is just split it down the middle, right? And you break it up into two equal triangles. They're all congruent. In an isosceles triangle, when you split it down the middle, you're going to get two exactly the same triangles. And so this will be theta over 2. Right? So this part, and these are all equal. So you can calculate this using trigonometry, right? Because the hypotenuse is 1. So sine theta over 2 is opposite over hypotenuse. And that's opposite over 1. So this thing here is actually sine theta over 2. This thing here. Sine theta over 2, 1 is sine theta over 2. So even this is sine theta over 2. So this AC can be calculated quickly. It's 2 sine theta over 2. Right? If you use a cosine formula, you can do it, but then you'll have to simplify a bit to get to 2 sine theta over 2. Okay, so you got that. That is the first thing. And then I observe that in this triangle here, I've got 1. These are 1. And this is also 1. All these equal sides are 1. This is 1. I got 30 degrees. And I've got one side. So in this triangle here, I've got 2 sides and an angle. It's not included, unfortunately, right? But you've got 2 sides and an angle. And you can use the sine formula, right, to calculate everything in this. In particular, I need to calculate this angle here. So I'm going to try to calculate this angle here. Okay. The angle of the triangle, which has got a dotted line, the 1, and this other side, which we calculated to be 2 sine theta over 2, got a 30 degrees here. So if you use a sine formula, you can calculate that angle in terms of theta. So what is it? The sine formula says A over sine A equals B over sine C is equal to C over sine B over sine B equals C over sine C. So if I use a sine rule for 1 over sine 30, one over sine 30 degrees is equal to 2 sine theta over 2. That's this over sine of the double angle. We call it sine of ADC. The sine here. Right? Opposite this over the sine opposite it. And sine 30 is a half. So 1 over sine 30 is just 2. So you got 2 equals 2 sine theta over 2 over that. The 2's cancel. And you let off with sine ADC is equal to sine theta over 2. And you'll conclude that ADC is theta over 2. And then you'll say, but wait a minute, theta over 2, this is theta. That's the original one is theta. Theta over 2 is a very small angle. How can this big angle like this be equal to theta over 2? You can see this is actually an obtuse angle. Yeah. So there's a problem here. And the reason why this is wrong is that ADC is not theta over 2. It's actually 180 minus theta over 2. The sine of an angle you see sine 40 is equal to sine of angle 180 minus 40. Sine is positive in the third quadrant also. So sine of an angle is the same as the sine of its supplement. I think you called it 180 minus. So this equation here, you could have said theta over 2. I'm sorry, ADC is actually 180 minus theta over 2. So this angle here is 180 minus theta over 2. Right? We want to get to that one. So we need to get this one now. Right? Okay, I've actually drawn a nice big diagram here so that we don't have any issues. Don't worry about this other thing for the time being. Let me make this a little bit bigger. I think I can make this a little bit bigger. Oh, I can't do it straight away. Yeah. Okay, I did do something like this. All right. So you got so what I do now is actually I do this in red, but I don't need that red for the time being. And what I've landed up was this one here. This is 180 minus theta over 2. Right. Now I want to try to calculate this one here now. Okay. So you got this, you got that. So let's try to calculate this first. Let's call this x. So you have x plus 30 plus 180 minus theta over 2. X plus 30 plus 180 minus theta over 2 is equal to 180. Angles of a triangle. 180 is cancelled. And you have that x is actually equal to theta over 2 minus 30. This angle here is theta over 2 minus 30. All right. Now let me try to calculate this y, this angle here. Right? In terms of theta. Now notice that x plus y, this whole angle here, plus this angle here, plus theta is 180. This is isosceles triangle. So this x plus y is the base angle of the isosceles triangle. So these two are equal. So twice this plus, remember that was theta right in the beginning. So you got x plus y is 180 minus theta divided by 2. Right, so you got x plus y. So therefore, you can calculate y. Y is 180 minus theta over 2, that minus x, which is minus theta over 2 plus 30. That's minus x. So I changed the sign, minus theta over 2 plus 30. So if you work this thing out, you get 90 plus 30, which is 120. Minus theta over 2 minus theta over 2 is minus theta. So this angle here is actually 120 minus theta. Right? So I can replace that angle by 120 minus theta. You don't ever see problems like this in school. So now I can actually calculate this angle here. Let's call this angle here Z. You see, I already calculated this. If I can calculate this, then I can calculate the one I'm looking for. Okay. And so let's see. Can I calculate Z? Yes, because this is an isosceles triangle. So Z plus Z, this plus that, plus this angle here is 180. Angles of a triangle, but this is isosceles triangle. So 2Z is equal to this. So what have you got? 2Z is equal to 60 plus 30, 60 plus theta. Bring it to that side. So therefore, Z is equal to 30 plus theta over 2. So this angle here is 30 plus theta over 2. All right, finally I got to this. It's a nice formula, nothing very too complicated. So now this is, now we've got two angles at that point, D. And we are trying to work out the third angle. So that's easy. Now we're almost there because we can just add these two angles up and subtract it from 360. And we add these two angles are already where 180 minus theta over 2 was, we worked this thing out earlier on. That angle there, we even got it there. And we just saw that Z is equal to 30 plus theta over 2. So the sum of these two angles is this, which is 210. Theta disappears. So these two angles, they add up to 210. And therefore, that angle there must be 150. So you can see, it's not an easy problem at all. You have to do a lot of, chasing, going all over the place to get to that angle. And this is the trigonometric way of doing it. And I'm going to stop there. There is also a geometric way of doing it. The geometric way is you have to perform a construction, and that is even more complicated. But if you want the geometric solution, write to me, and I will give you the geometric solution as well. Here's my email address, pillayph@ukzn.ac.za. That's my email address. And I can give you the solution to the other one. Okay, so I didn't do all the problems because we didn't have enough time. But all of them will take a considerable amount of time to solve. Okay, guys, I think I have one chat here. All right. I don't think you had any time to write down any more chats here. Okay, you can stay back and ask me any questions, and I'll be quite happy to address them. I must apologize for the difficulty of this problem, but unfortunately, we are not playing. Yeah. The team questions